Let's take a simple example. When we play football, what do you think you do to make a football move? So we often say that a force has been applied on a ball when it is kicked, pushed or thrown. Actions like throwing, picking, opening, shutting, kicking, hitting, lifting, pushing, pulling are often described as certain tasks. Each of these actions usually result in some kind of change in its state of motion. Like when we kick the ball, it starts to move from its resting position. All these actions can be grouped under push or pull. Like when you open a door, you are pulling it. And when you shut a door, it comes under pushing. So we can conclude that to move an object, it has to be pushed or pulled. In science, a push or a pull on an object is called a force. So we can say that an object moves due to the action of force. When we exert a force away from the body, it is known as push. For example, hitting a ball or kicking a soccer ball. That is an example of push. And when the force exerted towards the body, it is known as pull. For example, drawing a bucket of water from a well or playing tug of war. These are the example of pull. To explain it further, let's take an example. Suppose a man is standing behind the stationary car. Now, the car is not moving due to his presence. But suppose if the man now begins to push the car. He is applying a force on it, and the car may begin to move in the direction of the applied force. So in this case, we conclude that the man has to push the car to make it move. And in this case, the cow and the man appears to pull each other. From these examples, we can conclude that at least two objects must interact each other for a force to come into play. An interaction of one object with another object results in a force between the two objects. In the game of tug of war, there are two teams which try to pull the rope in opposite directions. Members of both the team try to pull the rope in their direction. Sometimes the rope doesn't simply move, but if one team applies larger force and pulls it harder, finally wins the game. Let's take one more example. Now there are two friends who are trying to move a heavy box that they can move only by pushing it. Now in first condition, both the friends are applying the force in the same direction. Now in this case, it is very easy for them to move it, because the forces applied on an object in the same direction add to one another. That's why they are able to move it quickly and easily. Now push the same objects, but these two friends are pushing it from the opposite direction. What will happen? In this case, the two forces are acting in the opposite direction on an object. The total force acting on it is the difference between the two forces. If the boys are applying same force from the opposite direction, then the object will not move. A force could be larger or smaller than the other or equal to each other. The strength of a force is expressed by its magnitude. If we change the direction or the magnitude of the force applied on the object, its effects will also change. So we can conclude that force has both magnitude and direction. A force can change the state of motion also. Let's take few examples. While taking a penalty kick in football, the player applies a force on the ball. Before being hit, the ball was at rest, so its speed was 0. When the player kicks a football, he applied some force on it and the ball moves toward the goal. Now suppose the goalkeeper jumps up to save the goal. By his action, the goalkeeper tries to apply a force on the moving ball. and the force applied by him or her can stop the ball or deflect it by saving a goal being scored. If the goalkeeper succeeds in stopping the ball, its speed reduces to 0. From these examples, we can conclude that force applied on an object may change its speed. If the force applied on the object is in the direction of its motion, the speed of the object increases. Like in first case, when the player kicks the ball, the speed of the ball increases. But if the force is applied in the opposite direction, then the speed of the object decreases. Like when the goalkeeper stopped the ball, the speed of the ball reduces to 0. In cricket, a batsman plays his shot by applying a force on the ball with a bat. The speed and direction of the moving ball changes due to the application of a force. So we can conclude that a force can bring change in the state of motion. And when we say the state of the motion of an object, it means its speed and the direction of motion. When the object is at 0 speed, it is called the state of rest. An object may be at rest or in motion. These two are its state of motion. When we apply force on any object, it may change its shape also. Take an inflated balloon and apply force by pressing it between your palms. What will happen? What do you observe? You will notice there is some change in the shape of the balloon. Same way, take a rubber ball, press it hard with your hands. Yeah, the shape will change. So we can infer that a force on an object may change its shape. So far we have discussed lot of examples. Let's recall it one by one. A force may make an object move from rest. When a tennis player hits the ball with his racket while serving. Force may change the speed of an object if it is moving. In tennis, player hit the ball with his racket and increases its speed. Force may change the direction of motion of an object too. In cricket, batsman hits the ball with his bat and increases his speed as well as change the direction of the ball. Force may bring about a change in the shape of an object. For example, when you press the Play-Doh with your finger, its shape will change. While a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of force. So, an object cannot move by itself. It cannot change its speed by itself. It cannot change direction by itself, and its shape cannot change by itself. For all these, a force is must. I hope you enjoyed learning today. Please like, share and subscribe to my channel. Thank you for watching.